A while back I did a video on scientific notation, and in the description I said it allows you to represent both extremely large and extremely small numbers. And I think the analogies I gave were the distance to the nearest galaxy and the length of a DNA strand. And it actually turns out both of those are a little ambiguous, because a DNA strand apparently is bunched up in a really tight ball, and it's only like 10 angstroms across, and an angstrom is like 10 to the minus 8 centimeters. A centimeter's almost a third of an inch, or a little bigger than a third of an inch. I think there's 2.54 centimeters in an inch. But it turns out, even though it's only 10 angstroms across, if you stretch out a DNA strand, it's tremendously long. It's amazingly long. It actually would be like 2 meters, which is like 6 feet long. So, if I met one, I wouldn't be able to see it, but it's pretty long. So I should have said the diameter of a DNA strand or something like that. And the distance to the nearest galaxy is about, if you take it to be Andromeda, it's like 2 million light years away, which is like 10 to the 19th, I think, miles. I'm not sure, miles or kilometers. And but it turns out there's another galaxy that's much closer, which is the Canis Major Dwarf Galaxy, which is only 25,000 light years away. And if you're in astronomy, you go, how can that be? It's only 30,000 light years to the center of the galaxy from Earth. So that would mean that the Canis Major Dwarf Galaxy was actually in the Milky Way galaxy, and it turns out that's true. It's a case of galactic cannibalism that's poor digestion. It's still not completely digested. But to get away from the digression, the first part of this is like the original program I showed, which is representing large numbers. And basically it has a e as an exponent in the scientific notation, and then a plus and a positive number if you're going to have numbers that are getting large. And anything to the 0 power is 1. So 4.37 to e plus 0 would be 4.37. And anything to the 1 power is itself, so 10 to the 1 power would be 10. So 10 times 4.37 would be 43.7. And so on. This would be 100, this would be 1,000, this would be 100,000, and this would be almost a billion, 100 million. And basically, because this is already a positive number, this would make these in the gig, the meg, and the k ranges for the 12, 9, and 6. But then when we get into negative exponents, we start to push the number past the decimal point to the right. And one way I think of it is that the number is the number of places you move it to the right. So 0, you don't move it at all. So a minus 0, which is actually meaningless. I halfway put this in to see if I would get an error. But minus 0 is the same as plus 0. It just takes it as 1. And so that would just leave it exactly as it is. It would be 4.37. But to the minus 1, it'd push it 1 place to the right. So it would be 0.437. And then another way I think of these minus exponents is they're the number of zeros in front of the number minus 1. So this would be 0 zeros in front of it. It'd just be 4.37. And 2 would be minus 1. So it'd be 1 0 in front of it. So it'd be 0.347, and so on. And I do the same numbers essentially going negative as positive. And one thing you'll notice is I had to use different string formats in the console write line, because n works great for positive numbers, but for negative numbers, if you're past 0.00, just 2 decimals to the right, it totally screws up. It just shows 0.00. So I put in these pattern characters of a pound sign, and basically the pound sign says if you have a significant digit, put the significant digit in, and fortunately it interprets zeros between the decimal point and the number as being significant, which of course they are. So if you don't have a significant digit, it just puts a blank, which makes the number look exactly the way I wanted it to. It's a unfortunately elaborate pattern. It seems like you should have some kind of field length on the pound signs, but I couldn't figure out a way of doing it or find any documentation on how to do it. So if we compile and run this program, I'll use the CSC compiler and right click to copy it from the clipboard. I already highlighted and hit enter to paste it into the clipboard. To copy it into the clipboard, and I right click to paste it. And if I hit enter, that compiles it. And then if I right click again and get rid of the CS, we can run it. And you'll see there are the positive numbers about the way I described them, going up to 4 gig, or 4 ter, actually a terabyte. And then here's the negative numbers, the negative exponents and the very small numbers. And as you can see, if you count the zeros, like in the -3, if you take 3 minus 1, that'd be 2 zeros, so it's 2 zeros and then the number. So my general principle works. This would be 11 zeros, although I don't feel like counting them out. Well, I hope you enjoyed this video and learned a lot. I don't know about the dissertation on astronomy and molecular biology, but in any case, I hope you enjoyed the video, and I'd appreciate it if you'd subscribe.